Okay. Now see, in this chapter we have done, this is the lecture number 4th I think so, और यहाँ पे हमें पढ़ना है VI graph. We are studying VI graph now. ठीक है. So in the VI graph, just a second. Yes. So in the VI graph we have the two things. Let me just make it there. Okay. So now we are having the VI graph. Okay. So in the VI graph, what we have, this is the y-axis, we all know. This is the x-axis. Okay. And then the y-axis, we also usually plot the voltage here, which is in volts. And on the x-axis, we usually plot the current, that is I. Who has joined? Nippon?
Yeah.
Okay. Take. So on the x-axis we show the current, and on the y-axis we show the voltage. So that's why we are showing like this I, and this is at the V. So it's called VI graph. Okay. Now this VI graph, the slope of this VI graph, this slope of VI graph gives you the resistance. The slope of VI gives you the resistance. Okay. How is it so? So see, when I used to take any of the 2 points, like this one here and this point here, similarly it's going from here and here. I've taken the pen. Okay, this. So now at this point, if I just consider here and this one part, so this whole part is the voltage and this whole part is for the current. Okay, and which is also be called as, because if this is an angle theta, so we are used to write that tan theta is equals to y upon x, but in the form of this slope we have, so we write slope is equals to y upon x. So in the slope gives the resistance, so we are writing resistance here, and instead of y we are writing the voltage here, and instead of the base, that is the x-axis, we are writing current here. So we got the formula that R is equals to V upon I. Got it, everyone?
Yes, sir.
It's the basic form of it, है ना? So it said the slope of V versus I graph. So that means what we can say here, the slope of V versus I graph gives resistance. Okay. Now, if I just do the inverse of it, then what will happen? So slope of I versus V graph gives you what? I just do the inverse na. So if see V upon I is equals to R, then I upon V will be equals to 1 upon R. Yes or no?
Yes, sir.
है ना?
Yes.
And this 1 upon R is also equals to G. Told you. This is
Yes, sir.
resistance, this is conductance.
Yes, sir. Yes, sir.
है ना? So you can just find, if IV graph is given, that you can just write it 1 upon R also, and if it's not there, then in terms of conductance you can write the conductance. So slope of I versus V graph will give you the conductance. Got it?
Yes, sir.
Yes.
Any issue with this one? Any issue? No? Now see what is happening here. If we have
Yes,
in,
sir.
in this condition, what we have taken the V and I as a constant value. Now if V and I is changing throughout them, then what will happen? So for the dynamic resistance, dynamic means whose value is changing, dynamic resistance whose value is changing. So what we are writing for dynamic resistance is delta V upon delta I equals to R. Got it? Why delta V and delta I means change in voltage upon change in current. ठीक है?
Yes, sir.
Got it, everyone?
Yeah, sir.
Okay. Now another point to remember is if greater is the greater is the slope of VI graph VI graph, then greater is the greater is the resistance of the conductor. Remember this, resistance of conductor. Okay, then greater is the resistance of what? Conductor. So see, if I just draw two like this, one is here and another is here. So which one? This is R1 and this is R2. Which one is be greater, R1 or R2?
R1.
Why? Who is having the greater slope?
R1 का ही तो है.
अच्छा, R1 का ग्रेटर है. एंगल किसका
एक
ज्यादा है? यहाँ पे गाड़ी
ओ
रखोगे वो नीचे पहले आएगी, यहाँ गाड़ी रखोगे वो पहले नीचे आएगी.
R2.
R2.
फिर है ना.
Okay, sir.
ठीक, चलो आगे देखें. इज इट क्लियर ना? नाउ ऑन द बेसिस ऑफ दिस, now see this V upon I and R is always given by the whom? Ohms only. Okay, so for this we got to know this thing that is called the ohmic conductors. Okay, or we can say ohmic resistor, ohmic conductors or non-ohmic, or we can say ohmic resistor or non-ohmic. So in your book it is given in the form of ohmic resistor. Okay, in the ICSE it's been talked about ohmic resistors. Okay, so simple, there's the same thing only. So conductor which obeys, okay, the Ohm's law, ठीक है, are called ohmic resistor or called ohmic resistor. Okay, got it everyone?
Yes, sir.
ठीक है. Or these ohmic resistors are also called linear resistor. Why linear? Because it shows the straight line, linear resistor. So it shows the straight line, that's why it's also called linear resistors. ठीक है. What are the examples? So conductor all metallic conductor. Who came, Rayo?
Sir, I changed my device.
Okay, ठीक है. So all metallic conductor like silver, silver, okay, aluminium, copper, iron, etc. Okay, so these are the metallic conductors. ठीक है, got it?
Yes, sir.
So these are the metallic conductors. What about the others? So other also shows the same thing, like for example a nichrome wire, it's a alloy, nichrome wire. Okay, then one more thing is there, CuSO4 solution, that is copper sulfate solution with copper electrode also shows the same. Why I am writing this? Because in the paper they going to ask whether this thing is ohmic resistor or not. तो अगर कॉपर सल्फेट सॉल्यूशन विद इलेक्ट्रोड लिखा आ गया तो क्या करते, अगर नहीं पढ़ा होता बुक में तो, है ना, दैट्स व्हाई.
सर,
हाँ,
अगर इसमें प्लैटिनम इलेक्ट्रोड आ गया तो
प्लेटिनम इलेक्ट्रोड आ गया तो प्लेटिनम क्या करेगा, प्लेटिनम इज नहीं
कि
करेगा.
में जो चैप्टर है उसमें दिया हुआ है प्लैटिनम और कॉपर इलेक्ट्रोड दोनों मतलब सेम टाइप से काम कर रहे हैं बट सॉल्यूशन का कलर बस चेंज होता है.
प्लेटिनम का देखना पड़ेगा मुझे, है ना? आई हैव टू सी फॉर द प्लेटिनम वन। देन इसी के संग में कॉपर सल्फेट के संग में वी यूज द डाइल्यूट सल्फ्यूरिक एसिड, दैट इज H2SO4, ठीक है? बट द
Yes,
थिंग
sir.
इज इन एवरीथिंग प्लेटिनम भी करेगा जहां तक है, बट द थिंग इज it should be at the constant temperature, so all should be at constant temperature, ठीक है?
Yes, sir.
Now what about the graph for these? So graph plotted for ohmic resistor, okay, ohmic resistor is a straight line, ठीक है?
Yes, sir.
स्ट्रेट लाइन, ठीक है? स्ट्रेट
Yes,
लाइन
sir.
passing through, write it in more form, passing through origin, passing through origin, clear है?
Yes,
Yes,
sir.
sir.
So the graph will, you can see, is like this. This is I, this is V. So graph will be a straight line, and this is R. So for every value of R, V and I will be constant. For every value of R, V and I are constant, because here it means V is proportional to I and R is constant. That's why. So whenever, see, R is constant for every value of V and I. This we can do. So R is constant. So V n proportional to I. That means whatever you are increasing for the voltage, the same will be increasing for the current, and same value will be the current, where R is the constant one. ठीक है? Got it, everyone?
Yes.
Yes, sir.
Then move to the next now. Then we have the non-ohmic resistor. So for the non-ohmic resistor, what is there? See, so for the non-ohmic conductor which do not, okay, obey Ohm's law are called non-ohmic resistor, ठीक है? Or we can say also called non-linear. Non-linear means not a straight line. Non-linear resistor. ठीक है? Done.
Yes,
Examples
sir.
are examples are for this LED, that is light emitting diode, solar cells, okay, junction diode which is being made up of semiconductor, that is also called PN junction diode, okay, PN junction, ठीक है? Then transistors and filament of bulb. Because why the filament of bulb? Because when you give the electric current to it, it start heating up, so temperature changes, so its resistance value also changes. That's why. ठीक है?
Yes, sir.
Clear है?
Yes.
हाँ. अब actually the things is, see, like this, so many material are there. Like Navda, you have asked for the platinum one, na? Like this,
Uh-huh.
many material are there, which you cannot just like been determined by like this only. So thing is, in the paper, if they're going to ask, they will going to ask from the topic which is being mentioned in the book only. Getting my point? इस
ठीक।
तरीके के क्वेश्चंस में जो वो ऑप्शंस देंगे, पूछेंगे भी तो वो वही पूछेंगे जो उनके बुक में या सिलेबस में दिया हुआ है, कहीं उस चीज का जिक्र हुआ है।
ठीक है।
नॉट बीन टॉकिंग अबाउट इट, दैट वोंट बी आस्किंग इट। ठीक है। हाँ, बट देन ऑल्सो आई जस्ट हैव अ वर्ड, सी कंफर्मेशन मुझे नहीं है, लेट मी सी दैट वन पार्ट, देन आई विल डेफिनेटली लेट यू नो। ठीक है।
ओके।
Now let's move towards the graph of them. So for graph, now it has been a straight or linear graph, it has. So for this, the graph for this graph is non-linear. Non-linear. That means that means what?
It's not
Not a straight. That means it's not a
straight line.
line. Okay, it's not a straight line. So it can be anything. It can be a curve. It can be anything. So like this, if we have drawn this, this is V, this is I. So graph can be like a curve or something. So it's been shown here like this. Okay, and this is the straight path. Okay, got it?
Yeah, sir.
Yes,
Everyone
sir.
got it?
Yeah, sir.
Yes.
Now, this graph is showing for the, this graph is an example of junction diode. Junction diode. Okay, now see, when you go to the class, senior classes, na, this VI graph will be in the form of like this, V, I and I. Okay, so it's will be in a form of like this. When you just study in class 12, it will be there. Okay, like this.
सर तो सिर्फ एक्स वाई जेड, एक्स वाई और जेड एक्सिस का ही चौथा कौन सा आ गया?
क्या क्या क्या
मतलब
क्या?
ये कार्टेशियन प्लेन पे बनेगा मतलब फिर।
हाँ, दैट इज बिकॉज V की वैल्यू नेगेटिव पॉजिटिव भी आती है उसमें जंक्शन डायोड में, इसलिए ये रिवर्स
ठीक।
ब्रेकडाउन अभी पढ़ोगे आगे जाके, दिस वर्क इन द रिवर्स ब्रेकडाउन रीजन। ऊपर का पार्ट क्या हो गया भाई? व्हाट हैपेंड? This is all a part of the reverse breakdown region. Okay, so this you are going to study. So these graph are not straight line. Okay, but sometimes this show the straight because of the values. ठीक है, तो हल्का सा पार्ट स्ट्रेट होता है, देन अगेन स्टार्ट्स टू चेंज। क्लियर है? हेलो
Yes.
एवरीवन, ठीक है? यस,
Yes,
नाउ
sir.
नेक्स्ट थिंग इज, now important एक note is there one, what? For ohmic, for ohmic, this resistance line should pass from origin, should pass from origin only, but for non-ohmic it is not mandatory. It can be passed from the zero, it can be from anyone. Okay, got it everyone?
Yes. Yes, sir.
Remember it, for ohmic it needs to be passed from the origin only, that is the O, and for the non-ohmic it is not compulsory, it can pass through it or it cannot, it can be any. Okay everyone, everyone got it?
Yes, sir.
What happened to everyone bhai? Na, got it? Now,
Yes, sir.
homework for everyone. What is that? Write difference between ohmic and non-ohmic resistor. Okay, with examples. With example. Can you all do this? This I want till tomorrow. ठीक है? Hello.
Okay, sir.
ठीक है? Now come to the interesting part. Okay? And the interesting part is what? Factors affecting the resistance of conductor. Factors affecting the resistance of a conductor. Okay, so there are four things. Okay, there are four things. First of all, see, if we talk about the resistance now, so we have R. Okay, this R is equals to rho L upon A. This is the formula which you need to learn right now. Now, let me write the things which on the factors. First factor. Okay, first one is the length of the conductor. That is what? That is what? That is R is proportional to L. That is R is proportional to L. That means if we increase the length, then resistance also increases. Resistance also increases. Got it, everyone? And comma vice versa. Everyone got it?
Yes, sir.
Yes, sir.
If you increase the length of the conductor, then resistance will also increase. So, for example, if I am having a copper wire of area of cross section A, length L, and the copper, it is a copper wire. Okay, then another copper wire I have taken, same material it is the material is same, that is of copper only. Area of cross section is also same, but the length is done 2L. So out of these, which is having the more? This is
The
the
12.
A1 and this is the B. So it's been cleared that length of conductor B is greater than conductor A, and both is made up of the same material, same area of cross section. So what is only changes here? Length. What only changes here? Length. So that means, and we know R is proportional to L, so
Yes.
resistance of B is greater than the resistance of A. Got it, everyone?
Yes, sir.
Yes, sir.
ठीक है? So what in the paper they may going to ask? See, it's important. This is important. Okay? What they're going to ask, if a conductor is, if the length of the conductor, we can say, if the length of the conductor is increased by 4 times of the original conductor of length L, then what? ठीक है, of length L, length L whose resistance is R, then what will be the new resistance? Okay, some sort of this question is going to ask. So I made it by my own right now. Okay, only this type of question. So the previous having the resistance R for L length. Yes or no? Any doubt?
No, sir.
4R. अच्छा, हाँ ठीक है. So R is proportional to L here, and we know if R increases, so for the first one, for L length of the conductor it is R. Now if the length is changed into the 4L, so now the resistance will become 4R. Okay, so it just means same because it's a proportional to each other. Got it everyone?
Yes, sir.
Yes, sir.
ठीक है, हाँ. Now second point. Second, area of cross section. ठीक है, area of cross section, that is R is inversely proportional to 1 upon A. R is inversely proportional to 1 upon A. That means if we increase the area of cross section, then resistance will decrease. Resistance will decrease.
Degree.
And vice versa. Vice versa means उसी का उल्टा. That means if you decrease the area of cross section, resistance will increase. है ना? Yes or no? यानी कि if you increase the area, resistance will decrease. If you decrease the area, resistance will increase. So this is going to happen. So for in this case, if I just take the scenario of this, if the area of cross section is A for a conductor and length is L, then another conductor of the same length is been taken of the same material, copper only, of the same material of length L only, and the area of cross section become double, and that is a B. So which is having more resistance now? A or B?
A.
A is having more resistance.
Yes,
Why?
sir.
Because it is inversely proportional. So out of these two, area of conductor A is lesser than B, conductor. So R is inversely proportional to 1 upon area. So resistance of A will be greater, है ना? Yes or no? Will be more than the resistance B,
Yes, sir.
है ना? So now what will
Yes,
be
sir.
the resistance here? So if for A, and A is, that is area of cross section is A only, so R will be, if it is inverse, है ना? So now in this second case, not the first one, second case को लो ना इसमें. So second case वाले में R कितना हो जाएगा अब? R will be 1/2. Yes? Yes or no?
Yes.
For C.
Yes, sir.
Nipun Nitish, clear?
Yes, sir.
है ना? So R will be 1/2. Now if I took area of cross section 3, then R will become 1/3. Yes or no?
Yes, sir.
And if I reduce the area, so area become 1/4 of the conductor, then R will become 4. Just remember this one part. ठीक है? Got it everyone?
Yes. Yes, sir.
Any doubt?
No, sir.
Now, so we have done this two part. Third one is nature of conductor. Nature of conductor. What is the nature of conductor then? See, different material has different sort of the resistance. Different material has different sort of the resistance. Yes or no?
Yes,
Some
sir.
are good conductors, some are good insulators, or we can say some are good conductors, some are bad conductors. So if it's a good conductor, so that means we can say good conductor. Good conductor will have less resistance or more resistance,
Less resistance.
है ना? And bad conductor will have,
More resistance.
because it doesn't let the current to flow, and that is the function of the resistance. And that's why if the current do not flow totally, so it becomes insulators. So on the basis of that, got it? Like good conductor कौन कौन से हमारे पास? Material which have low resistance value. कौन कौन से हमारे पास वो? सिल्वर Ag, कॉपर Cu, yes, yes or no? एल्यूमिनियम, ठीक है, लेड, ठीक है. So these are
Yes,
the
sir.
good conductor. These are the good conductor. And when we say the good conductor, when it has free electrons. It has free electrons because free
Ele-
electron can only conduct the electricity. Okay, got it?
Yes, sir.
Then
Yes, sir.
insulator में कुछ भी डाल दो आप, insulator के नहीं वो वैल्यू जिसके अंदर free electrons नहीं होते. Okay, the next one is, so got it everyone? Nature of the conductor.
Yes, sir.
Hmm. Then we have temperature of conductor. Temperature of conductor. So see, in case of conductors, what happened? ठीक, अब जैसे ही आप टेम्परेचर बढ़ाओगे, सी ऑलरेडी वी हैव फ्री इलेक्ट्रॉन्स इन द कंडक्टर्स, ऑलरेडी वी हैव फ्री इलेक्ट्रॉन्स. अब जैसे ही आप टेम्परेचर बढ़ाओगे तो बॉन्ड और टूटेंगे, यस, एंड द इलेक्ट्रॉन विल
Yes,
बिकम मोर फ्री. और ज्यादा इकट्ठी भीड़ बढ़ जाएगी तो नंबर ऑफ कोलिजन्स बढ़ जाएंगे, टकराव बढ़ जाएंगे कि नहीं?
yes, sir.
So due to which what will happen? Resistance will increase in
Ha,
conductor. Resistance will increase in conductor.
conductor.
Okay. So when we increase the temperature, of a conductor, okay, so the random motion, because more will get the more kinetic energy, the bond will break or bond is not breaking, then the electrons will get the more kinetic energy. Both the conditions are there. So random motion of electron will increase. Okay, electron will increase. ठीक है, that means they will gain the kinetic energy, they will get the kinetic energy more. Okay, got it?
Yes, sir.
Now due to which
Yes, sir.
what happened beta? Hello, yes, due to which number of collision of electron, okay, with positive ion, with positive ion लिख दिया मैंने, positive ion, okay, with positive ion also increases. Okay, positive ions will increases. So now collision will increase. So what will happen? Suppose this is a conductor, and when this is positive charge, this is positive, this is positive, this is positive, suppose, and the electrons are moving and striking here, then striking here, striking here, striking here. So what is happening? the path will be provided the collision. When the more collision is there, that means there will be the slow in the path of the electron. The path of the electron will slow it down. Path of the electron will slow it down. Due to which what will happen? Due to which what will happen? Resistance will increase. Resistance will increase. Okay.
Yes,
So
sir.
so this collision increase the time for flow of electron, thus thus increasing its resistance value. Okay, so with increase in temperature, resistance also increases. Got it, everyone? Everyone got
Yes, sir.
it?
Yes, sir.
ठीक है? So that's why the resistance of the filament of the bulb is more when it is been on and it become less when it is off. ठीक है? Clear,
Yes,
everyone?
sir.
हाँ,
Yes, sir.
एक बल्ब का resistance will be more when it is on and the resistance will be less when it is off. Clear?
Yes, sir.
Sir.
Now from tomorrow we will study. अभी हम उसको नहीं कर रहे हैं. Now tomorrow was the topic for the VI graph of for a conductor at two temperature. VI graph for a conductor at two temperature. ठीक है? This was the smallest, and then we'll move toward the resistivity, which is the important part also, and most of time you will get confused with the resistivity part. Okay?
Yes, sir.
Hmm. So till tomorrow your first part will be finished, that is the first A. Sorry, not first A, this chapter it is, that is B. A1 part will be finished, then we'll move towards the B part. Only two parts is there, है ना? A and B. No, C is also there. हाँ, C is also there. It's a lengthy chapter a bit. No issue, we'll do it. Okay guys, so any doubt till now?
When